Hello, everyone. Welcome back to another episode of the AI Sana podcast. I am so honored to have somebody in this podcast with us today who I would consider comes from a long history and royalty lineage in the robotic space. Kevin, thank you so much for joining us.
Oh, you're welcome, Nee. Thank you very much for having me.
Kevin, I know you and we've met last year at Carnegie Mellon, and for the students here, if you are in the AI space, you would have inarguably heard of Carnegie Mellon. It is the number one, literally the number one school in the world for AI and robotics. And Kevin here is entrenched in that ecosystem through his undergraduate training, master's training, PhD training. Now he lives in that city. He helps support robotics and startups in that city. And so I'll ask him to go through this history. But today's topic is the market mapping of the construction industry, and robotics plays a really strong role in that. So we're lucky to have Kevin. Kevin, before we start about the topic on construction, tell us a little bit about yourself.
Sure. I grew up outside of New York City, and I had the opportunity in high school to look at a bunch of different schools, and I chose Carnegie Mellon not for any particular reason, but because my girlfriend at the time, now my wife, was actually looking at art schools, and she told me about this school called Carnegie Mellon.
So it worked out pretty well for you. That was a good investment.
Very well. And she mentioned Carnegie Mellon, and I said, "Where's that?" And she said, well, it has a very good art school. It's in Pittsburgh, Pennsylvania. So it turned out, and I didn't know this at the time, it had a pretty good engineering school, pretty good science school. And so I came to Carnegie Mellon too. So we also were undergrads together. But we ended up being at Carnegie Mellon at a very propitious time. We had the formation of the Robotics Institute at that time. And Carnegie Mellon was also emerging on the national stage. It was a very good regional college like MIT and others, was a technical school, but then it began to branch out into many areas. And today, of course, it's internationally known and respected for many things that it does. But at that time, it wasn't really as well known as it is today. But I happened to be there at a time when they announced a robotics institute. I was still an undergraduate at the time, and I saw this little article in the student newspaper about a robotics institute. It literally was one sentence in the newspaper, but it so grabbed me. I knew immediately that's what I wanted to do. So I figured out who was who, and I pestered some people, and I ended up having a summer job that year as an undergrad working in the Robotics Institute as it was being formed. And I had the very fortunate circumstance of being there as things were growing. And I worked with a number of researchers at the time, people who are very well known in the field, Takeo Kanade in vision, for example, later Red Whitaker in field robotics, and Raj Reddy, one of the pioneers of artificial intelligence. So I was doing all kinds of little things. Remember, I was just an undergraduate, so I'm an idiot. What do I know? And I'm learning every day. One of the other things that happened, which did affect me in a big way, was I was constantly being asked to give tours of the Institute because I was very familiar with all the projects and all the people and what was going on, what was coming in. And that communication effort helped me a great deal to better communicate with others because I could describe the projects both technically and what it meant socially and so forth. So I ended up with many years of doing that. I worked initially for a researcher named Art Sanderson. Art is not as well known perhaps as some others today, but he was a pioneer in using robotics for assembly tasks and other things, which I helped to build those systems and program them in some cases.
It's wild to hear you say Art was a pioneer in using robotics for assembly because now I think most people kind of think of robotics for assembly.
That's true, yeah. If you think about robotics on automotive lines, for example,
Yeah.
it's ubiquitous.
Yeah.
You don't do a painting and welding on a car these days in a factory without robots.
Right.
Economically not feasible, really. And so working with Art was, and his group, the grad students I grew up with, was just a tremendous amount of fun. And again, I learned a lot. We had a very interesting researcher coming from Stanford, from where he just graduated, who was a pioneer in autonomous vision-guided mobile robots. That was Hans Moravec. And if for those of you who are not familiar with him, you should look him up. He is the really often called the pioneer, the father, really, of autonomous mobile robots, using vision-guided robots. Remember, this is back in the early 80s. There's not much power in computing. You have more power in the phone in your pocket than 1,000 of the computers had at that time, even the mainframes. And so that work was fascinating. I ended up working with Hans closely over a number of years, building indoor mobile robots to do navigation. We sometimes took them out on the sidewalks using a robot built by another group, by Red Whitaker, who I later also joined to build some of the first roadworthy autonomous vehicles. And it was just fascinating to be part of that and grow with that, both in my own career, my own knowledge, but also seeing the Institute grow and continue to succeed at building systems, autonomous systems. And it was fascinating to watch this. As I grew in my capabilities, I was able to take part in a number of projects for DARPA, for National Science Foundation, Department of Energy, NASA, and others, which gave me a lot of exposure to many of these different agencies, how they worked. And also, I'll point out something interesting that many people don't know is that the Robotics Institute began with 100% corporate funding from one company, Westinghouse. No government funding at the time. And Westinghouse at that time was a conglomerate, much like we might think of General Electric, which itself is sort of shrinking in focus. But Westinghouse realized it had a productivity issue across all of its businesses, which included jet engines and light bulbs, believe it or not, and appliances and avionics for fighter jets. And so we had a wide variety of projects with really interesting technical challenges that we would build systems to do, turbine blade inspection and so forth. I wasn't part of the turbine blade piece, but I knew the researchers quite well. I was helping them out on their projects. All of this led to a lot of interest in robotics and driving. And we sort of had, and by the late 80s, though, robotics had fallen out of favor. The AI winter had begun. People had said certain things like neural nets won't work. Well, Jeff Hinton, who was at Carnegie Mellon for a number of years, proved them wrong in that eventually. And as we know today, what we know as AI, what we think is all AI today, is in large part responsible for this, the ability to have neural nets that work because they're multi-layers deep and our computers are many orders of magnitude faster.
Yeah. So Kevin, I as you're going through this, I mean, I'm like, I'm just giddy inside because, when I introduced you, I said you come from just this royalty lineage in robotics, but you come from royalty lineage in robotics and AI. And I know sometimes that people kind of include robotics and AI together, but I mean, you've mentioned you were there at the formation of the world's oldest and leading robotics research institute, the world, globally. You were there and you got your undergrad, master's, and PhD at Carnegie Mellon, which is the number one school in AI and robotics. And you came to Carnegie Mellon at the time when robotics really was an established industry, sector, discipline, and Carnegie Mellon is not the behemoth that it is known for in AI and robotics now. You were there working with someone who invented the concept of robotics for assembly. Another person who's invented the concept for vision guided robotics for mobility. Another person who is one of the godfathers of AI and did this argument for in defense of neural nets that gave rise to many other godfathers and godmothers of AI. I mean, when we say royalty, I mean, we mean you come from line of royalty.
Well, I think the circumstances were very fortunate. A conversation in high school led to my being there. I happened to notice this thing and became really excited about participating in this robotics venture. The other thing I point out is that I did a job search after my undergraduate, which was in applied mathematics at the time.
Okay.
I'd taken on a lot of engineering courses. I loved to.
There was no AI. There was no AI major back in the time.
Well, the computers, I took classes in AI when I was there. There was
Wow.
a Red Book by Patrick Winston, which was the canonical AI book at the
Yeah.
time.
Yeah. So when people say, oh, AI was invented in 22, 23, I mean, you chuckle at that because
Oh my gosh. Yeah, people, I don't know what happens. Maybe it's a lost generation or something, but if you look at the work of Herbert Simon and Newell and McCarthy at Stanford and Minsky at MIT, this was the mid 50s they did this work. Of course,
yeah.
I wasn't born then, I was even around then, but you can trace a lot of that back. And CMU, MIT, and Stanford all had excellent growing artificial intelligence things. The term artificial intelligence was coined in the mid 50s at a conference at Dartmouth,
Yeah.
and a very famous conference. But people don't realize there was means ends analysis, there was modeling the world, vision, systems, speech recognition, things we take for granted today. There's a famous quote often attributed to McCarthy and at least one other person, which says, AI essentially is what we've succeeded at, but then it's no longer called AI.
Yeah.
So when we have speech recognition and we talk to our phones, say Siri, please do this, or Alexa, please do that. That speech recognition part, that was AI.
Yes.
It took many breakthroughs, included hidden Markov models by Kai-Fu Lee and many others to make that an acceptable commercial endeavor. And you can trace back the lineage of speech recognition and image understanding to much of the work done at both CMU and other places as well.
Yeah. Yeah, you're absolutely. I love that, you gave the example of talking to your phone. The founder of our firm, Antoine Blondeau, he founded Alpha Intelligence Capital in 2018. His
Mm-hmm.
first foray into AI is he 30 years before that, in the 90s, he worked on a project commercializing DARPA funded research in a project called Callow that became the foundation model that is Siri. And so when people say,
Mm-hmm.
again, they say, oh, ChatGPT's release was the advent of AI. It's
Right.
funny to hear that.
It is certainly a milestone. I don't want to diminish it, but at the same time, don't forget that there were thousands of autonomous miles on vehicles, tens of thousands. Years before, the DARPA challenges that CMU entered and occasionally won, there were many projects with NASA and others. There was a really interesting project, which you can still find on the internet. Todd Yocum and Dean Pomerleau were two grad students at CMU. They drove from coast to coast. It was called No Hands Across America. And the idea was that they took a Chevy, I think it was a Chevy minivan, and instrumented it with some of the neural network research that Dean had done for years with Todd. And they drove from the East Coast to the West Coast 98% of the way, I think it was slightly higher than 98%, autonomously. Now, this was on interstate highways, which are probably the best marked, well laid out, consistent roads in the country.
But still, I mean, 98%, that's wild. I mean, I don't know if you could even do that today, drive across the country
That's a great question. I think the models are certainly better today, and people are obviously deploying cars in city streets. And I would argue that Pittsburgh has one of the most diverse set of street construction in the world. We have
98%.
cobblestones and asphalt and concrete and brick. We have a wooden street, one of
Yes.
the very few left in the world. When you're next here in Pittsburgh, Nee, I'll take you over to Ellsworth. There's a small street on the side of that that's made from wooden blocks.
That's crazy. You also have a lot of undergrads who sometimes forget to look both ways.
Yes, that's true. Unfortunately, I think the LiDARs and cameras that we use today detect that, so
Yes, yes.
they're still safe.
I was shocked, I mean, obviously you when you go to like San Francisco and cities like that, you see a lot of Waymos, but those Waymos look very new. I was last there in Pittsburgh. Your Waymos look worn. They have been around for a long time. And I know we're talking about robotics right now. We should be talking about construction, but
Well,
there's a long history of robotics, and especially robotics in construction and manufacturing, in Pittsburgh.
that's right. And I would, if I look back at the work done with Caterpillar, later John Deere and others, they were focused on things like excavation and trenching and digging. And within civil engineering, which is where Red Whitaker began his work that went beyond his PhD research, he was focused on going into unstructured environments where there was no map, there was no knowledge of what was going there. Some of the first were some of the remote vehicles for 3 Mile Island, there was a nuclear accident here in Pennsylvania back in the late 70s, and that had been basically shut down completely. I was only on the periphery of those projects. I remember one Easter weekend, we all came in and were polishing stainless steel for the 72 hours straight, basically, to make sure that they could withstand washdown. But it was fascinating to see, to deploy them into those environments. The ones that actually went into the radioactive environments were taken away and buried. I don't know where they are today.
Yeah.
Um, but Red was very focused on dealing with robots that exerted force on the environment, not just flying eyeballs, whether driven or flown. It was that you would change the environment that you were actually in. And that was done through excavation, work with Caterpillar and others, and loading and so forth. But we began by building smaller refrigerator-sized robots. Terragator was one of the early ones, which would go out and navigate sidewalks or
Mhm.
paths in the park nearby. We have a very large urban park here next to campus. And being able to do these pieces and elements to make the underlying technology better and better was a big aim of ours. Moving, it's hard for people to understand, I think, because we were doing mainframe computers, which were not powerful enough, but we were sending wireless transmissions into buildings to connect to the machine rooms where all the big computers were, the more powerful ones. And later we built a vehicle, the Nav Lab, which I was leading the construction of that vehicle, which was housing racks that had Sun workstations and warp machines built by H.T. Kung, now at Harvard. And these very fast, at that time, very fast workstations were able to compute some of the images, the very first LiDAR ever used on a autonomous robot vehicle. There's many stories behind all of that, but it's fascinating to see that. That LiDAR, the size of a microwave oven and tiny fraction of the resolution of the LiDARs we have today, has given way to something you can hold in your hand and navigate by. Yeah. And the cost continues to come down, the capabilities continue to improve, and cameras. Obviously, the camera in our phone today is equal to that of high-end digital cameras of 10, 20 years ago. Yeah. So I sound like my father talking about what it was like years ago, but it's true. I mean, there's so much we take for granted today that was uncovered, developed, and then produced in volume to help not just robotics applications, but many applications. Better sensors leads to better factories, for example. So.
Yeah, better sensors also lead to better healthcare, better food and ag, processes. I think, our students have heard about some of the innovations in AI and robotics for some of these verticals, but when you talk about the context of being there at the beginning when people are starting to adopt novel technological approaches for robotics, it is so fascinating to hear. I know we could keep going on this for a long time. But I want to shift the conversation just a little bit towards a little bit more about the work that you're doing now. But before we do, I will say we got to give great thanks to your wife for bringing you to Carnegie Mellon, putting that on your radar to begin with. So kudos to her on that. So thank you to her. But let's talk a little bit about where you're at now. You went through your undergrad, master's, PhD. What did you do after that? Where are you now? What do you focus your time?
One of the things I realized, I loved Carnegie Mellon. I bleed plaid. Plaid is really the color of CMU's at Tartan because of its Scottish heritage with Andrew Carnegie. And I decided a good part of the way through my PhD, I was doing the research, writing the thesis, and doing experiments. It was on snake type robots. I realized that's not
how
what I
he chose
wanted.
it. With how he chose it and his
So
team?
there's an interesting connection here. Howie's advisor at Caltech, Joel Burdick, was one of my committee members.
Okay.
Howie came to CMU right around the time, actually, that I was wrapping up my thesis. Joel was the committee member, and Howie came, and he also took on snake-like robots because Joel had been working on sort of these multidimensional ways to do sort of a mathematical mapping to control the gaits, GAITS, the gaits of snakes, which turn out, even though they have no legs, they actually do a variety of motions in order to locomote. That was one of the things that I was covering. But I realized I didn't want to stay in academia. I love the research. I love the projects we were doing, the robots we were building, and also automating existing machinery like an excavator. We're not going to design an excavator. Looks like Caterpillar know how to do that better than anyone, and other construction equipment companies. So here's the dilemma I faced: is like, what do I do in the real world versus academia? And I looked around quite a bit. I looked at a position in MIT, Microsoft, and others. I subsequently chose a company in the Boston area that was working on robots for the fabs. These are the chip fabs where chips are made, where wafers are moved around. It was a surprisingly still very manual process of moving wafers around the fab to complete the recipes to build the chips on the wafer, which are then sliced and diced and packaged elsewhere in the world. And I thought that was a fascinating environment. It's unlike the dull and dirty, maybe even dangerous applications of robotics. This was ultra clean, where the air was filtered. You wore bunny suits and you walked into the fabs to basically move things around, and everything's enclosed. So I thought that was a fascinating environment. I ended up doing a number of things in the semiconductor industry as a result of that experience. But we designed and built mechanisms to grab pods of wafers on a sort of a monorail that hung above the machines, and these things called FOUPs, front opening universal pods, which housed maybe $1 million worth of wafers. By the time they made their way down the production line and these 400-step recipes to do lithography and so forth to build them, um, they became more valuable. So if you dropped a pot of a dozen 200 or 300 millimeter wafers, that was $1 million worth of chips, especially if there were Pentiums at the time. So that tells you a little bit how long ago it was. And inevitably, automation came to the fab, and you don't operate a fab without a large portion of the operation being automated today. But then I had an offer I could not turn down. It was to join a little startup in Boston, which is where I had moved to after finishing my doctorate at CMU. And I met with the CEO who I knew from Carnegie Mellon. There was a couple of folks from Carnegie Mellon that I knew very well that worked in our lab here. And I was the functional manager for electronics for our lab in the Field Robotics Center for a time. And I met up with him, met him at his small apartment in the north end of Boston, which is really the Italian section, lots of great food, and it's just a very lively area. And he showed me this little disc with very bright LEDs on them. Of course, I knew what LEDs were. What I hadn't realized is how bright they had been becoming. And red, green, and blue, and you can control them, make any color. And I was hooked. I thought, well, as in the words of our later CFO, were we all betting that disco is coming back? And because you can control these things infinitely. I'll make a long story short. The company succeeded amazingly well. Looking from the outside, it looked like a rocket ship taking off. Went public in 2004. We were acquired by Philips, the very large company based in the Netherlands.
What was the startup company called?
Oh, I'm sorry, Color Kinetics.
Color Kinetics, okay.
So Color Kinetics, sort of homegrown in Boston. I hired a number of folks, many out of Carnegie Mellon, because I knew they could do the job. Here's an interesting observation that I had is I loved people with robotics backgrounds because they would think of systems rather than just components. They would think about integration of all these technologies, sensors and active components and so forth. It wasn't just engineering and working on one thing and then saying, this is the best I can do for this component. No, it was thinking about all the components together. This came up again and again and again. And I realized one of the greatest lessons I had by working at CMU was integration of technologies is really a discipline in itself, and that systems thinking was incredibly important, that you weren't necessarily picking the very best for each job, you were picking the system-wide implications of these components in order to make the best overall system.
Yep. Yep. And I think, for context, it's the equivalence of, do you pick the biggest battery with the longest range, or you pick the battery that has the appropriate range, appropriate weight for, let's say, something in mobility.
Exactly. And that's actually a great example because the bigger battery means bigger mass, bigger size, bigger volume. So you've just negated some of the things that you were trying to do. So how do you work all of that together? There's no closed form solution. It comes from a lot of experience and, of course, a lot of testing to find out where is the sweet spot for optimizing this particular system. And of course, we all want battery technology to be better, so we're always looking for the next big thing. But I think there's a lot of ways in which you can think about systems and integration to make vastly improve. And in robotics, that's more important, I think, than almost anything else, because it is such a mixed set of ingredients to form what is the best solution for a particular problem. So I was at CK, Color Kinetics, we called it CK, for a number of years. After we were acquired, I learned quite a bit. I ended up being in Amsterdam and Eindhoven, their technical hub, quite a bit because I was learning a lot about the international aspects of the business. I like to say sometimes that CK, Color Kinetics, was my MBA. I started an MBA program when I moved to Boston, but I realized I couldn't see my family. I had an hour and a half commute into Boston because we could afford a house that far. And all of that. So I did take a handful of courses, but that was about it. I'm glad I did what I did because I could not have continued to do what I did without sort of giving up something. MBA, I realized in the end I didn't really need it. But I did learn a lot from those courses. I remember once catching our CFO in an error where assets and liabilities didn't add up to the equity.
Okay.
So that was like accounting 101. And I just said, "Oh, what's going on here with this number?" And then he quickly grabbed all the papers, ran out of the room, and I think fixed the pretty obvious error.
Oh, thank goodness, thank goodness. See, those courses came in handy.
It,
The Color Kinetics was acquired. You worked with the acquiring company, and the acquiring company was Philips.
it was which the largest at that time, the largest lighting company in the world.
And so and Philips is a still very well recognized quality
Oh
brand
yeah,
today. So Color Kinetics was acquired by Philips. You worked with Philips after the transition, and how does that lead back? When and how does that lead you back to Carnegie Mellon, Pittsburgh Robotics Factory?
after Philips, I joined a startup in Cambridge, which had some really exciting technology from a well-known researcher, John Rogers, who was at UIUC at the time, later went to Northwestern. It was the confluence of electronics and materials to form the basis for sensors and other devices that could go on the body or in the body.
Mm,
And it was exciting. You know, at that time, we didn't call it this, but the word wasn't quite used in this way. It was really a platform technology where you could do many things from it.
mm.
The danger with that, and this is where I ended up disagreeing with our CEO, who I liked and respected quite a bit, but his turn of phrase was preserve optionality,
Okay.
which sounded good in principle. Okay, well, we're going to be opportunistic and find the right market, and then that's what we're going to go after. To me, it felt like we're skating on thinner and thinner ice. I don't want to sound like I'm diminishing it in any way, but in the end, I transitioned out of the company. We had some disagreements on this because I had a small team, 15, 20 people. We were trying to do too many things in cosmetics and solar arrays, military work, medical work, clinical work.
Wow.
we
Wow.
actually we were actually going to launch. We actually got to the commercial markets where we launched a product with Reebok to do impact detection on the head. The idea was a TBI, traumatic brain injury, and so forth, leading from concussions. Was a very challenging thing at the time. It is still today, right?
Yeah.
How do you make sure that athletes are safe
Yeah.
when they're doing their sports?
Yeah. But I mean that's so broad. I mean to preserve optionality and that leading to, sports tech, healthcare, cosmetics, solar panels. I mean that is so broad. I can't even imagine how you would stock inventory enough to even
No, you
launch all
can't.
those products.
Each one of those is a very different vertical, right? You have to figure out how do you go to market. And of
Yeah.
course, the principle was we'd explore all these things until we figured out what the right market to go after was. I really enjoyed the clinical part of it. I left the company, and then a few years later, they got acquired by a company for that particular application.
Oh,
It was,
oh,
you know,
that's fantastic. Good news for them. So you're a PhD in, two startups in, one acquisition in, and what do you do? What do you do with your life?
So I was talking with a friend from Pittsburgh, Henry Thorne, and the history of Henry goes back quite far. We were undergraduates together at Carnegie Mellon. When he graduated, I believe with his master's actually, he ended up going to Flint, Michigan to help General Motors with their welding lines and
Mhm.
created a controller which was a big time saver and money saver for GM. But he wanted to do something more and he was thinking about personal robots at the time, a little like iRobot, which was gestating right around the same time. You know, Helen Greiner and Colin Angle out of MIT were building that, along with their advisor, Rod Brooks, who's another great character in the robotics timeline. And Henry had this idea, and I said, look, there's this program here called it wasn't called Innovation Works at the time, it was called Ben Franklin Partnership. And I wrote a proposal to them, it was accepted, and that brought Henry to Pittsburgh. And we ended up doing some of the personal robot piece, but he was a little ahead of his time on that. And ultimately, the personal robot thing didn't go well, but I was also now focused on my education and working on other things. But Henry stayed on. He founded a couple of companies, including one called Four Moms, which was building products for very young children, really toddlers and babies. And I thought it was very interesting. It was also consumer products, which was challenging. We'd done some of that. I'll probably try to avoid consumer products in the future.
Okay.
It's very challenging for many reasons and so many variables. But in the end, I got a call from Henry, and after I left MC10, and he said, "I want you to come back to Pittsburgh." And I talked to my wife, Mary Jo, about it. We said, "Sure." We liked Pittsburgh a lot. We liked Carnegie Mellon a lot. We liked the whole thing. So I ended up running engineering for Four Moms for a couple of years, and then it had some big financial problems for a time. After I left that, I was called by Rich Lunak, who was the CEO for Innovation Works previously, and they brought aboard someone else, Ven Raju, who was initially their CIO, and he said, you two should have lunch."
Okay.
Sure. So we're having a great conversation. We're having a nice lunch, this Ben and I talking. And toward the end of the conversation, he said, "Well, I want you to run this robotics factory program." And I said, "Well, tell me about it." And initially, I wasn't sure about it. It was one thing I loved about it was helping startups, and I've been doing that. I've been investing personally in some companies at the time, and so I joined as a consultant. And I said, let's do a 6 month sort of trial period. You can decide if you want me or vice versa. And I realized just 6 or 8 weeks in that I wanted to do that full time.
Okay.
So that was June of 2023. I decided by August to transition into a full time role here. And today I am the managing director of the Robotics Factory, which does many things.
So help us understand what is it? You said, innovation works. You said the term innovation works and then robotics factory. What are those entities? What do y'all do?
So Innovation Works has been one of the longest serving investment activities here in Pennsylvania. They're seed stage investments, basically. And it's been operating since the mid 80s, early to mid 80s. There was a name change from the Ben Franklin partnership that I mentioned earlier to Innovation Works right around 2000. It has become one of the most active seed stage investors, not just in the region or in the state of Pennsylvania, but the country. 35 to 40 active deals per year, but
Wow.
not in money terms. So a single investment by a Silicon Valley company or investment VC firm would be far more than we would deploy in a year.
Yeah.
Our numbers, our dollars are less, but our deals are much
The
more.
deal volume is very big. I mean, that 30 to 40 is oftentimes like the entire fund number of deals that a fund would do over the course of 4 to 5 years.
Right. Exactly. So we've been working on that. I've become much more involved in the investment side as well, making decisions around that. We're trying to solidify the process to make it more efficient, faster, and so forth. And we've been able to do that. Now, the Robotics Factory was a different program. It was a federally funded. But let me back up 1 second. Innovation Works is primarily state funded. Money comes from the DCED within Pennsylvania. That's a Department of Community for Economic Development here in Pennsylvania, and they deploy funding to all areas of Pennsylvania, including southwestern Pennsylvania, which is where Pittsburgh is. And in
And
doing
for our students in context, our students are in Kazakhstan. They might not be familiar with where geographically in the United States Pennsylvania is. So where is that?
so Pennsylvania is sometimes called the Keystone State because around the time of the formation of the country, it held a position in sort of midway between the northeastern states, New England, and states to the south, Maryland, Delaware, Washington D.C. itself, and so forth. So the Keystone State is sort of in the middle, but it's one of the largest states on the East Coast in terms of area. Pennsylvania itself is long too. So Philadelphia and Pittsburgh people recognize as being from Pennsylvania. They're at opposite ends of the state. They're about 5 hours apart driving.
Okay, okay.
It's a good distance. That's not suggesting that my car is really bad. It's really that's the time it takes to drive on the highways to get from one city to the other. And you're crossing a very, very old mountain range at the same time, the Appalachian Mountains.
Yep. And I mentioned that because the work that you do in robotics and AI, it stems from an area that was historically big in manufacturing in steel, and that background in manufacturing and steelworks, it's really crucial for the hardware side of the robotics. You also now are kind of in the middle, really along that entire coast of the eastern coast of the United States, along financial government hubs, including New York, Washington, D.C., Atlanta, with the CDC for healthcare. So you're really centralized to be able to leverage AI and robotics to apply to verticals that are important for each of those hubs.
That's right. Driving distance to many of those cities you just named New York, even Boston, is within a day's drive. So having that capability. Pittsburgh itself is sort of perched on the western side of the Appalachian Mountains. So it's sometimes considered a Midwestern city, but it really isn't. We're still separate from the Ohio border, which is really where the Midwest begins. But also to the east, back to the toward the East Coast, it's really also there too. And you brought up a really good point about the history of Pittsburgh, which is why I ended up at a place called Carnegie Mellon, because Andrew Carnegie, of course, was one of the most successful entrepreneurs in history, grew a steel industry vastly. And there's a great debt of gratitude owed to that capability, which came in manufacturing, as you pointed out. He made the raw materials, took the raw materials like iron and so forth to create steel right here in Pittsburgh. And Pittsburgh is located not because there's iron here, but because there's coal, and that was used to fire the steel mills and run them. That legacy, along with Mellon, the Mellon family was a banking family which became immensely wealthy based on investments in aluminum. Alcoa was based here for well over a century. So it was a materials-based economy. Mm-hmm. You had Frick with the coal fields, you had Carnegie with the steel mills, and many others too. I'm leaving a lot of folks out of this. But that whole history led to a legacy of foundations and entities that created many other businesses, including manufacturing, which serviced these industries. And even still today, there are hundreds, maybe thousands of companies in the region that do a wide variety of things. We're not strong in semiconductors or as strong in sort of life sciences as you might think, but even today, the biggest industries in Pittsburgh are now becoming medical, education, and tech. It's really no longer, steel is no longer really atop that list. And so it's been a really interesting path to watch that happen over the past few decades here.
Yeah. And I think, with you and Robotics Factory in 23, such timely, it's such a timely occurrence because, in 23, people were talking more about the open AIs and the open AI wrappers, etc. But now there's massive demand for physical AI, how to bridge the software and hardware stack surrounding robotics and robotics' ability to execute. So I think that, the fact that you came back to Carnegie Mellon and to Pittsburgh in 23 and with the rise of the robotics factory, it's just so timely.
You know,
You've got a knack for timing.
well, I made the decision to leave Pittsburgh. We loved Pittsburgh. We had a house, we had renovated it, and so forth back in the late 90s when I left. And the reason for that was I didn't see an emerging ecosystem around robotics at the time. There were two, maybe three companies that were sort of robotics related. Red Zone, of course, was one of them, still exists today. But I saw in Boston, which was also New England, near where I grew up, that there was a lot going on in this area. And that's why I moved. But when I was looking to come back, and of course I started to notice the proliferation of robotics companies. It's now today, here we are in early 2026, there's over 100 robotics companies. There's probably even more AI related companies.
Yeah.
And so it's sort of rich hunting ground for investments and so forth. But
and some of the biggest names in AI and robotics in the world. I mean, you think Aurora for car autonomous vehicles. You think of Gecko Robotics. You think of there's just so many. I mean, you've got so many robotics companies that are literally household names at this point in terms of how they are for what counts as startups and companies.
There's Latitude, Stack AV, Motional have offices here. It's interesting to me if you look at autonomous vehicles is a great thing because there was such a lot of media about it over the past several years that what we saw was a number of the diaspora from Carnegie Mellon, people leaving Carnegie Mellon looking to form companies, did them here. Uber established an advanced technology group here that later was acquired by Aurora, although
let Aurora tell that story. That one becomes a little hairy.
Yeah, well, it's also interesting because Uber said, "Here's 450 million bucks, and you can have this too." So
yes.
less an acquisition than a magnificent gift.
Yes, yes, and please do something with what we've already built because we're leaving.
That's right, and they have. Aurora is now running trucks in Texas, multiple trucks, I believe, right now across highways.
I think the last time I was in Pittsburgh, I was on a panel with Aurora CEO, and they were 10.3 billion. 10.3 billion is a lot. Wow. That is a massive valuation.
Wow. That is amazing. You know, considering we were exploring sidewalks around campus at centimeters per second,
Yes.
you know, just a couple of decades earlier, it really shows you how far we've come.
Yeah, and now autonomous trucking, cross country, long haul autonomous trucking has very different universe than exploring millimeters of sidewalks.
Right, that's right.
So Kevin, I want to just shift a little bit back to when we talk about robotics factory. You said robotics factory does some investments. Sorry, innovation work does some investments. What does robotics factory do as part of innovation works' portfolio of program?
Right. So the federally funded program that was behind the formation of the robotics factory had three programs. One is called Create. This is a very interesting model where we bring robotics entrepreneurs together with industry leaders in particular sectors. I'll give one example. We held an aviation summit here in 2023. That was in the spring, and we had airlines and airports, you know, Changi in Singapore. We had people from Heathrow. We had people from American Airlines and others, basically saying, here are the challenges we face. It's sort of a reverse pitch, but it's much, much more than that. The comprehension and the post-summit activities sort of belie what we're able to do with these summits. And basically, those innovation leaders in that particular industry would basically say, here are the challenges. And in that, the robotics entrepreneurs are thinking, okay, can I solve that? Is this amenable to robotics? And in some cases, yes. So one of the problems that was brought up was baggage handling. We had a small group from a company that came out of a company called RE Squared, which had been acquired by Sarcos. That deal ultimately didn't work out well for RE Squared because Sarcos did a pivot to software only, and that really took a very good presence here. That was RE Squared, which is a hardware-based company that also does software. But this small group said, we can take on baggage handling. We've already been thinking about that a little bit, but here's what we're going to do. They formed a company now called Journey Robotics. They went through our accelerator, and then we helped them scale and prototype the initial devices that were subsequently deployed at Pittsburgh Airport into the British Airways area for luggage and baggage. That has now led to further investments.
Is this Reed Allen's company?
Yes, Rig Allen is the CEO, and Keith Gunnett and several others are all part of that.
This podcast is evolving in such interesting ways. And I think, for our students who are listening, we never know. We never know where the conversation is going to lead us. And if you, Kevin, I know that we have you for an hour and a half. If you are okay with it, I would like to do this in a two-part series.
Okay.
Now that we're talking about Journey Robotics and the handling, I'd like to do a little bit of a case study on that because it's such a unique problem and the solution is so innovative. And then what I would like to do is then transition into the conversation around the construction market mapping, if you're okay with it. So perhaps students, bear with us. And Kevin, thank you for your patience as well. I'm kind of throwing a little ball into this game here. Journey Robotics, when you said that, we're thinking about kind of innovations, and they discovered this baggage handling and came out of R Squared that got acquired. How did they even identify that as a problem? Like, who thinks of this? How do they even know what the value chain was, what the problems were? Like, how did they even connect with British Airways? Like, take us back to what you know about.
Those are great points. I may not have all of the information. Rig and others at RE Squared had looked at a number of airline issues, being wastewater and deployment of other sensors on airplanes. It was interesting that we had the workshop at the Create Summit. We identified one thing was almost a throwaway problem, which I had never, it just astonished me that it was a problem. People are stealing the life-saving part of the seat, which might have a life jacket, and they're taking with them. So they have to check under the seats to make sure that they're still there. And this is a very, very annoying and also potentially life-threatening issue.
Is that a common issue? People actually taking the underseat stuff?
I was shocked as you were. It's like, why would you do that?
Why would you
endanger someone?
But also, what would you use it for after you?
Well, exactly. Like, you use it as a lifesaver.
Yeah, and we're talking about literally when you're on an airplane, when the attendants say, in case of an emergency or water crash, look under your seat. There's a life preserver, like
you
that.
Should check.
Oh my gosh! Okay.
It was it was shocking actually to hear this. But what we decided was that wasn't really a robotic system. Yeah, you could imagine some sort of thing that would inspect under the seats and so forth. But the idea that we threw out there collectively was a RFID tag, so you could check it on, make sure that it wasn't leaving the plane. And I believe I've heard, I don't know for a fact, but that Boeing is looking into a solution very much like
And you can also, I can imagine an RFID tag on a life vest or a life preserver is important because if it's deployed, you can check when it's deployed and you can track the people who are floating in the water. So it seems kind of like a useful
yeah,
solution.
it could be. It's a small expense for such an important thing, but if people hadn't been stealing it, we wouldn't be talking about it here today. It's like
Yes, that's
that's so
so,
weird.
which is so fascinating to me because our students have in this podcast series they hear a lot of other case studies of how companies have like identified their problem, looked at the value chain, realized that was an opportunity for innovation, and a lot of times it sounds like, hey, I knew this industry really well, I've known this was a problem, I was forced to solve it. In this case, it's like this is a really life-threatening problem, but it's such a petty thing that
It
customers
is.
do that have there's no rhyme or reason why customers would do it.
Right, right. It's like having a rental space. Some folks in my family have a home, a second home that they often rent out, and then they'll come back to the home and like stuff's stolen. It's
Yeah,
like,
but stuff that doesn't matter, like the remote to a TV that is a very specific brand and is not like a universal remote. Why would someone take that?
right, right. All these kinds of things happen. So
Yeah,
but it was so interesting to see these challenges because we had never heard of this. Having the domain knowledge matters, and very often robotics companies are formed with very little knowledge of that particular domain. Sometimes that can be an advantage where you're not constrained by conventional thinking in that
yeah.
particular area. But on the whole, like color kinetics, I'll go back to that example. We didn't have anyone from the lighting industry for several years early into it. We were just fumbling our way through trying to understand what people wanted. And we did well, but it was very lucky. I mean, at some point, we did need to have people with experience in that industry. And I would argue that any entrepreneur should have that.
Is that a factor of the fact that robotics itself requires so much knowledge around the physical engineering of the system? Or what why would robotics companies uniquely have an overabundance of or a lack of expertise in the industry that they ultimately go in to solve the problems?
I think the assumption that, oh, I see how we can improve that process with a robot, so we'll just do that without really understanding the business, the mechanics of working into that industry, how business is done there, on what basis. And without that, I think you're at a disadvantage until you have someone who can point out a few things to you about that particular business.
So then if we go to Journey Robotics, so with this summit, there were ideas kind of floating around that you didn't even realize were problems. And how did Journey land on baggage handling for their robot?
I'll have to recall this, but I believe that that was presented to them at one point as a problem. They said, well, we don't know exactly how to solve that, but perhaps, engineers naturally want to sort of dive deep quickly and offer a solution.
Yeah.
But I think what they did instead was instead of saying, oh, we're just going to use an arm and we'll have it grab a bag and put it over here, they worked with airlines. And that aviation summit was a great way to meet some of those people. So IAG, for example, was there, and they're the parent organization for British Airways, one of the largest carriers in the world. But hearing it straight from the people at British Airways it made the decisions that they had to make about the system more
Yeah.
focused, more constrained, and that actually freed them up to explore those rather than trying to expand capabilities. All too often, and I was guilty of this too, like, oh, this could be used for this and this and this, but
Yeah.
if it just, focus on the one that's going to be your beachhead market that will enable you to be successful, be trusted, and then you can expand. But you try to do everything all at once, and it usually does not work.
Like what you were saying about the company that you were working with where you preserve optionality.
Right, right.
So on this, in the baggage handling space, what's the status quo? And what are the areas of inefficiency that was so crucial that IAG sent someone to the summit to find? a startup to build something specific for their problem?
First, we were very fortunate to have a trade association. This became the model for later summits. A trade association in that business who were able to contact everyone, and so they
Mm,
had deep contacts with them. We, myself in particular, I don't have a lot of contacts in the airline industry. I could probably call around and get some, but they knew who to contact immediately. So they were the ones who said, you should come to this. Here's why. This is being put on by a group in Pittsburgh that is well known for investing in startups and so forth. They have good connections with Carnegie Mellon, one of the leading universities in these areas. And so that's how it really began. Those connections were made through that. And then bringing in airlines and airports. So interesting thing that again I didn't know was that who pays for the systems on the airports? Is it the airlines or the airports? It turns out it depends. It depends on
oh,
which airport. It's not there's no one thing because gates can change from one airline to another over time as companies go
oh,
out of
that's
business or
true.
change operations. So who owns the property? It's usually not the airlines, it's usually the airport. But on the other hand, there are many cases in which the airlines will pay for equipment to service their planes and so
Yeah.
forth.
And but the airlines employ the handlers, the baggage handlers for their specific. So there's it seems like it's one big co-working space for a lot of
Right.
airlines, right?
And that reminds me, you had asked the question, what is the status quo of baggage handling today? It is mostly manual, almost entirely manual, other than the conveyors, but they have to be unloaded from the holds within the plane.
Yeah.
Sometimes there are things called LPDs. These are basically look like small container, not small, but they're good sized containers that hold a lot of baggage. Those
Yeah.
are often removed, and then those could be shuttled around. But then eventually the baggage has to be taken out of those, and they're often put on trailers that are linked together like a small train,
Yeah.
pulled by tuggers
You
around
see
the.
those. I mean, it's entirely manual because even when you say the conveyor belts, I mean those people have a little car that is attached to the conveyor belt, and then you
Right.
drive it up to the plane, and you kind of position in place, and then you turn it on, and then it starts doing. So a lot of it is there's not really a whole lot of actual like non-human intelligent automation in that process.
Correct. That's absolutely right. And don't forget, too, that those jobs, there's a lot of turnover there. You're lifting, I think the limit is either 25 kilos or 50 pounds, which people, my wife has a crane scale kind of thing
Yeah.
where you lift it up and she gets to 49.9 pounds
Yeah,
on
yeah.
it. And so a lot of people do that. So you're lifting and moving 8 hours a day on your shift,
Yep.
50 pounds of luggage around
Hundred, and for every flight, I mean, you're doing up to 300 of these in any weather, right?
That's
Rain,
right.
snow, ice, really hot, brutal sun. I mean, you're doing this round the clock. That's brutal. So
Yep.
okay, now I can see what you said about, baggage handling. The issues of baggage handling come from one, the fact that despite the abundance of robotics and automation resources available globally, it's not very well and widespread deployed in baggage handling. Two is the turnover and the human impact of that job is very, very, very high.
Right. That's right. So we had identified this challenge at the end of the Create Summits. We have it's a very well structured workshop where they actually have homework to do. And subsequently, we have many business plans that are presented to the entire crowd. And we have a little sort of challenge going on, which one is the best and so forth. Some of these are investable and some of these ideas and companies have come out of this. There's much more to do. And then to your earlier point about construction, we held one of these summits on the subject of construction industry. And the construction industry is amazing.
Let's, you know what, I want to finish our story on
On
the
Journey.
baggage handling, if that's okay,
Okay.
on the case study of Journey Robotics, and then shift into construction. So maybe let's spend the next 5 minutes finishing up this story of Journey Robotics. So Journey Robotics at this aviation summit, they were essentially reverse pitched a problem, and they identified this as an area to solve. There really wasn't a whole lot of one competition because the status quo was literally physically manual human
Right.
labor. So what is their solution, and what are kind of the signals that tell you that their solution now works?
So they were looking at putting in their time and their own money into forming a company and finding a solution. And they were working on this. And we began to work with them to prototype a gripper that could quickly grab and then extract a baggage from a big pile of baggage, and we were helping them with that. And they really felt like there was a good solution here. But basically, the model was using a larger industrial arm combined with this very specialized gripper. Carrying, remember, you're carrying this gripper, which itself is pretty heavy, along
Yeah.
with the 50 pounds of baggage, or 20,
Yeah.
roughly 25 kilos of baggage in addition to that. And then you had to grab it, swing, and drop it onto a
Yeah.
conveyor belt where it was
And
supposed
it has to be fairly mobile enough because when you think about baggage handling, there's a lot of different areas for baggage handling. And I think that people they're like grippers in robotics and AI, it's you there's a lot of them, but you usually see them for like produce handling or small package handling, or you see them for kind of major car manufacturing man. But in both of those scenarios, these are static arms bolted in place. They're not going anywhere. They don't need the flexibility to be able to go from one conveyor belt to another, one aircraft to another.
correct. But they do need a little bit of motion. The fundamental concept that eventually evolved from all this thinking and prototyping was that of a 6 degree of freedom arm. A degree of freedom is obviously the individual motions that an arm can make, and concatenated together with a linear transport device, which could move it over in just a couple of meters, maybe three meters or so. So
Okay.
you were able to reach into a trailer, grab a baggage, swing the arm, move it, and then drop it on the conveyor belt. So it didn't give.
What used to be a fully human process of take let's say loading unloading from a plane onto a trailer, driving that trailer into kind of the baggage terminal, taking the bag off the trailer and then into the conveyor belts that then ultimately end up where the customers get it. Then the manual part now is reduced to unloading off the plane onto the trailer, and then
Correct.
the rest of it can be automated.
Correct, because the trailers were pulled by a human driving the tug, which would then park next to the
Yeah.
robot. The robot
Perfect.
would then, and the principle is that it would empty that thing onto the conveyor, and the conveyors would direct that particular thing due to scanning of tags and so forth to its appropriate
Yeah.
destination.
So then you used to think, let's say that the lifespan of a worker, or I guess not the health span
Mhm.
of a worker in that role could used to be a couple years. You can now extend that double because they're essentially doing half of the labor. Not that you cut the jobs, is that they still have to be there to manage it, but the physical impact on your customer, the healthcare impact, the benefits coverage that the company would have to provide would
Oh yeah,
have because of the automation.
that's right. And there are well documented health risks to that particular profession too, which is one of the reasons for the high turnover.
Yeah.
Doing that for a couple of years. In a subsequent summit on a different subject, we watched a short video from a very large food company showing a woman in a constrained space unfolding a box, putting the flaps down, taping it, moving it over here, filling it, packing it up, putting it over here. And just, I think most professional athletes would
Yeah.
end up
It,
crying
it's
after doing
brutal.
this for 8 hours.
Yeah, it's brutal. My family, we're immigrants from Vietnam, and when we moved to America, my mother worked in a dye and mold company. And so these companies would make printed parts for lots of different applications. And she specifically made the ink cartridges that would go in cash registers. And she did that for 6 years. And I mean, she literally sat doing the exact same motion for day in and day out, 12 hours a day, 6 days a week.
Wow.
Years. I mean, even now, I mean, this is 20 years later. She still has bruises on the bottom of her legs where her legs would press into the edge of her chair.
Oh, boy.
So the physical impact of repeatable motion tied to human labor is there's the economic impact, there's the human psychological, and then there's the physical healthcare long-term impact of it. Let me ask you what this other question. With Journey Robotics, where are they now, and how do you know their AI and robotics enabled solution is solving the problem and providing value?
I'll answer that last part first, which is because it's been deployed at an airport. It's been actively working at the BA, British Airways section for baggage at the Pittsburgh International Airport. And they're right now in discussion. I'm not sure I can be public about this yet, but let's just say a major terminus in Europe, which is very, very exciting. And they're also in the midst of raising a significant round, which will get them to their next stage and milestones. And some of that investment is coming from these strategics. So they're keenly interested in this.
Yes. I love that you semi alluded to determinists in Europe that might or might not be tied to some of the people who helped them discover the solution.
Right.
I know the terminus you're talking about, and that is one that has like a long term reputation for people losing their luggage.
Boy, yeah, I can see that. I've learned, you probably too. I've learned to travel over many years by doing carry on
Yes,
everything.
yes.
I
If
could,
you're going to go through this particular airport in particular, you should do carry. Okay, so you know it works because it's been deployed. You know the proof of value because it's been deployed. They you know it's valuable to the people who have tasked them with the problem because there is now a funding round and strategics in the space who understand this vertical and understand the problem are coming into it. That
right.
Kevin, thank you so much for covering that. I think that isn't just such a compelling case story, case study, and story around your very long history and very prolific history in robotics and in startups, in how it led to you working with the Journey Robotics team through Robotics Factory. Now, I want to just pause
I,
here and call this part one of a part two of Kevin.
but I can add to that because the journey with Journey has not finished. It's ongoing. We accepted them into our accelerator, the robotics accelerator, and they went through a 6 month curriculum to learn more about non technical subjects, basically related
Mhm.
generally to business. So if you think about sales and marketing, customer discovery, that's our strong emphasis. And that accelerate portion is also part of the robotics factory
Ah,
for the robotics accelerator. So Journey came out of a Create Summit. We helped them with prototyping. They go into the accelerator. They come out of well armed with other skills and experiences that they're now using. They're raising funding. We have further invested in them as well. And then the scale program, which is the third component of the robotics factory, besides create and accelerate, we basically help them to prototype, to engineer some
mm,
elements of their gripper, for example. So our support of them doesn't end with any of those particular pieces of it. We extend that. What we're trying to do in general is de-risk a startup. A
yeah,
startup can fail in so many ways. There's probably as many ways to fail as there are startups.
yeah,
One of my favorite quotes is the Anna Karenina principle, based on the Russian novel, which is all happy families are alike, meaning that your successes are because you succeeded or didn't fail at least with all of these things that you had to do to create your business. However, there are many failed companies, but they all can fail for different reasons.
yeah,
It could be marketing, it could be engineering, it could be timing,
yeah,
all kinds of things. So,
yeah.
all
It's so amazing, the comprehensive suite of services and support that you provide through Robotics Factory. And our students have heard of accelerators as one of
mhm.
those resources in the ecosystem that they can lean on as they're going through their entrepreneur journey. But you're so unique in two aspects, well, three aspects. One, you yourself and your extensive understanding of the space, your prior startup experience, etc. Two is um, hardware is one that a lot of accelerators don't focus on because how, like, they don't know how, they don't have the resources. And third ties to that concept of no knowledge and resource. I mean, if you're helping with the problem identification through your summit, you're helping with the actual acceleration program through your ability to do programming that a lot of traditional accelerators do, but you specifically have access to investors, collaborators, etc., in the robotic space, and you have the domain expertise. And last but not least, in the scale seems so crucial because it's almost as if it's a real world large scale, using that word, maker space, but it's professionalized in helping actually create the physical products, and
Right.
most accelerators don't do that.
That's right. There is often the term used makerspace, but I really feel that this is different. It's a production
It's
prototyping
production space.
workshop,
Yeah,
right?
it's production workshop. It's kind of shared production, and that's
Right.
amazing. That's amazing. Think about it as if students, if you're familiar with co-working spaces. Co-working spaces, usually you share kind of kitchens and office and conference and desks, and in this case you're sharing like major manufacturing equipment and
That's right.
processes and staff and tooling, and even like warehousing for inventory. I mean, that's amazing. Kevin, I want to pause here and call this part one
Okay.
of our podcast, and then I want to, if it's okay, let's shift into the robotics. So students, let's pause here. Let's tune in for. Thank you so much for tuning in. I know that originally we designed this as a the construction market map. We'll come back for part two. Kevin and I will look pretty similar to this part one, but you will tune back in for part two on the construction market map. For this part one, we've discussed the topic of Kevin's very, very prolific history in AI and robotics, Carnegie Mellon's very prolific history in AI and robotics, and the evolution of what Kevin has seen in terms of the emergence of some of the major topics that and major technologies that you see now that we just assume have just been around forever because they're so ubiquitous, including using vision for guided transportation and mobility, using robotics automation for factory and assemblies. It's crazy to think that you were at some point someone said maybe we should do this and other people might have said, oh, I don't know if that would ever work. And so now it's everywhere. Kevin, thank you so much for joining for us for part one. Students, tune in for part two.
Thank you.